Today is balik ano tayo? Balik buhay estudyante, no? At our last discussion, or at least our last in-depth discussion, was way back before the midterm exam. I think that is the first week of September. Then second week is your midterm exam. And then week after we do not have a class. Week after that is Typhoon Christine last week. So we only had Sunday classes, and then next is this week. But we do not have classes yesterday because of the all the Souls Day. So basically we are still not most of us are still not in the mood to go back to school, I can say. So hopefully starting today, moving forward is little by little we get back into the mood or the game of school, because I think we only have around 5 weeks to go before your final exam. And within those 5 weeks, we will be discussing a lot of things because, well, I think we have enough rest or break already. Okay, since after the midterm, so hopefully we get back into the game, and because we have a lot of things to discuss, and with that a lot of class work to do. Okay, so for this week our topic would be fluid flow fundamentals. So this is, last week we discussed about the fluid flow concepts. However, we did not do any calculations during that time. So this week will be the time to do calculations about those topics. But before we dive into that, we want I want to show the agenda for today. First is, before this is to revisit midterm exam statistics. Okay. Next is to give you a quick review, of the rate of flow concepts. Third is to understand and solve rate of flow problems involving fluids. And of course, fourth is to learn fluid behavior in multipath or branching scenarios. So first is the midterm statistics. Midterm statistics. Okay, so midterm exam, I have finished checking. I have already also uploaded the raw grades to the Google Classroom. Please remember that those raw grades are based on a denominator of 75 instead of a 100, because item number 3, as I discussed last week, will be waived because the instruction and the given assumptions are not complete. So it will be unfair to you if I included that in the total grades. So because of that, only 3 problems will be solved or checked. However, any solution to item number 3 can be added as a bonus. For like whatever effort you have for number 3 will be added as a bonus. So, but this denominator will still be 75%. With that in mind, for your class, PET E3106, the highest grade obtained is 60. Okay, 60 over 75, which is a good grade, a high grade. To being considered as passed, you have to obtain 60% of the total grades. So 60% of 75, that would be 45. And for your class, one, two, three, 4 people got grades 45 and up. So congratulations to those 4. Highest grade again is 60 over 75. Lowest grade is 19 over 75. Average or mean for the class is 30.47. So not very bad. I've seen worse in the past. Okay, so this can be easily um, pulled up by your future or upcoming classworks. Okay, we have still a lot of, we are not halfway through the classworks yet. You're already finished with your quiz 1, problem set 1, and quiz 2. We still have quiz 3 this week, problem set 2 after next week, quiz 4 after that, and then quiz 5 again will be based on the Google Classroom questions, and problem set number 3 will be based on recitation. Ah, so there are more, I mean, we are not halfway through the quizzes and problem sets, so there are a lot of up up uh, room to go up, to pull up your midterm grade. Of course, there's still the final exam, which I hope uh, you will be performing better compared to the midterm exam. Okay, but for all of your finished classwork, you can check the scores. I have checked all the keys already, except for yeah, including problem set, including problem set. Just a moment. I think problem set one is included. I'll check later. Okay. So if you have questions or concerns about your grade, comparing your answers with the answer keys, if you see a big discrepancy, feel free to raise your questions in the private comments of that um, affected classwork. So I can review later this week if the grade needs to be revised. So any questions or concerns so far regarding your scores or grades? Okay, so if no more questions, then we move forward to a quick review of rate of flow. Okay, rate of flow is something we discussed last week. It is the quantity of fluid that is flowing through a point over a unit of time. Okay, and we said we can show it or express it in three different forms: volume flow rate, mass flow rate, and weight flow rate. Okay. Volume flow rate is area times velocity. Okay. So velocity gives the element of time, and then the length dimension in the velocity times the two length measurements in area gives the volume. So this is actually volume over time. Okay, A times V, volume over velocity times area. Okay. From your volume flow rate, you can multiply that with density and you will get mass flow rate. Okay, so it can be expressed as rho times area times velocity, or rho times volume flow rate. And lastly, if you multiply your mass flow rate with gravitational acceleration, you will get the weight flow rate. Okay, that's G. Okay, which is density times area times velocity, or mass flow rate times gravitational constant. We can also express that as rho times G times Q, or G times mass flow rate. Any confusion or questions with all of these three rates of flow?
None po.
Okay. Now, following the rate of flow, we move forward to the continuity equation. The continuity equation is based on the assumption of ideal flow, meaning we will not be considering frictions. Incompressible flow, meaning the density is constant. Laminar flow means that the flow is organized or in laminations or small small entropy. Steady flow means that the flow parameters are constant with respect to time, and this is applicable for both uniform and non-uniform flow. Again, uniform and non-uniform flow is based on the consistency, or if the flow parameter is constant with respect to position, or basically point A, point B. Okay, so this is valid for both uniform and non-uniform flow. Okay, so based on this, our assumption is that the flow rate at A is equal to the flow rate at B. Okay, it means whatever volume is passing through point A, that same volume must be passing through point B to meet or um, to follow the continuity equation. Okay. Again, Q, or volume flow rate, can be expressed as area times velocity. So that's A times velocity of A. Velocity of A equal to area of B times velocity of B. Okay. And for an incompressible fluid where the density is constant, we can extend it more to mass flow of A equal to mass flow of B. Okay. As long as the densities at point A and B are constant, we can extend it to mass flow rate. But initially, it's only the what's this, volume flow rate. But if the density is constant, you can also use mass flow rate. Okay. So volume flow rate is applicable even if the densities are different. However, the mass flow rate, this is only applicable if the densities are same. So that would be for incompressible fluids. Okay. Any questions or clarifications? Okay. So we now go to example number one. If there's an example, then there will be a recitation. Okay, the velocity of a liquid with SG 1.4 at in a 150 millimeter diameter pipe is zero point 0.8 meters per second. Calculate the rate of flow in liters per second, cubic meters per second, kilograms per second, and kilonewtons per second to significant decimal digits. Okay, so for the first one, let's first do these two: cubic meters per second and liters per second. So these are the volume flow rates in two different units. Okay. So looking at your recitation list, I think there's still a balance of participation for all groups. So for today's participation, to, I will not specify a certain group to answer. Anyone in the class can volunteer to help discuss the example. So for the first one, who would like to help us solve the volume flow rate of this liquid? Anyone po? Nobody? Nobody, nobody? Wala. Okay, let me start this one. Okay? So initially we need the volume flow rate of the liquid. So for the volume flow rate, it is given by area times velocity. Okay? My velocity is already here, 8.8 meters per second. So I need the area, ay sorry, velocity. Velocity. Tama, ito nga. 0.8 meters per second. So I need the area. Okay? And the area would be given by the diameter of the pipe. Okay? So my equation would now be area times velocity. Velocity being 0.8 meters per second. Area given by pi r squared or pi d squared over 4. Okay? So this will be my given. Ay, I forgot to mention pala that today, since I do not have my pencil to do the whiteboard, we will not be doing the whiteboard yet. So the examples, the solutions are in the PowerPoint muna until I get my magic pencil back. Okay, so when doing recitation, we just tell the process, then I will show the solution. Okay, it will not be impromptu solution like before for now. Okay. So again, rate of flow is area times velocity. That will be pi d squared over 4. For me, I am more comfortable using pi d squared over 4 because most of the areas that we will use will be based on diameter. So for me to not need to convert it to radius anymore, I used pi d squared over 4. Okay. Then multiply that with the velocity 0.8 meters per second, then we get 0.01414 cubic meters per second. Using this volume flow rate, we just convert it to liters by multiplying it to 1000 liters per 1 cubic meter. And we get 14.14 liters per second. So these two values are the values of the at the volume flow rates of our fluids. So next one, can someone help us solve for mass flow rate and uh, weight flow rate? Yes po, Alfred. Hello.
Sir, dun po sa mass flow rate po.
Mm,
Bali po, sa same na po yung sagot dun sa volume flow rate. Ang
yes.
gagawin lang po ay, gagawin po ulit cubic meter,
Okay, yes, this one.
tapos po itatime sa 1.4 times 1,000 po.
Okay, which is the density of the liquid. So what will be the answer po? If you do that.
19.79 po.
Okay, so ito yan. Okay, so mass flow rate will be density times our existing volume flow rate. So 19.79 kilogram per second is our mass flow rate. So next naman po, so this is correct. Next naman po is how do we you convert it to weight flow rate? Alfred pa rin.
Share ko po ulit.
Yes po.
Sir, gagawin po ay ita-times lang po sa 9.81.
Okay, so what will be the numeric answer doon?
194.16 po.
Okay, 194.16. But remember that is still newtons per second. We are being asked for kilonewtons. So we need to convert your 194.16 or 50 natin to 0.194 kilonewtons. Okay, salamat Kil. Okay, any questions po regarding this one? So ito naman, medyo straightforward siya. Basically, use the existing variables. Multiply mo lang siya with density and gravity. Depende kung anong kailangan mo. Example number 2 naman is if we are able to do it for liquids, we should be able to do it also for gases. However, for gases, again, we have a challenge because the density of gases is not fixed or changes depending on the temperature and pressure. So because of this, if you have a gas as your fluid, you have to go through the ideal gas law equation to determine the effective density of the gas. Okay? So, which is something that we already discussed during the first part of the semester. Okay? So, first part, question states nitrogen at 40 degrees Celsius and under a pressure of 3,000 millibars flows in a 350 millimeter diameter conduit at a mean velocity of 8 meters per second. Find the mass flow rate in kilograms per second, 3 decimal places. Of course, since this is a gas, I need to give you a gas constant, and that is for nitrogen 0.297 kilojoules per kilogram Kelvin. Okay. So again, to iterate the given, I have already converted everything into their SI equivalents. The 40 degrees Celsius is equivalent to 313.15 kelvins. The 3000 millibar, is 3 bars, which is equal to 300 kilo Newton per meter squared or 300 kilopascals or 300,000 pascals. Our diameter is 0.35 meters, velocity is 8 meters per second, and our gas constant is 0.297 kilopascals meter cube per kilogram Kelvin. So would anyone want to help discuss the next steps? Oops. Anyone po, nakalimutan na ata ang ideal gas law? Aldrin.
Sir, ano po? Kukunin po yung volume po. Gamit po ang PBMRT.
Ang goal natin sa our goal for in the ideal gas law, okay, is to get the density.
Density.
Okay, density. So, the ideal gas law kasi, it states PV, MRT.
PBMRT.
So, may V and M doon, which we can use to show density. If you would rearrange the terms, if you would rearrange the terms, do you remember kung anong form para density? For density using ideal gas law? Yes. Sige, Daniel, let's help Aldrin.
Sir, yung po yung P over RT po, pag sa density po.
Okay. So, PVMRT siya, pero if you would isolate mass over volume, mass over volume, ang litira sa'yo sa other side would be P, pressure over R, or gas constant times temperature. Okay? So, yan. So, sige. Daniel, can you solve po for the value of P over RT based on this given?
Ano po, sir? 3.2256 po.
Wait lang. Okay, wait lang. 3.2256. Ito yan. Okay, PVMRT. Rearranging the terms, our density, our mass over volume will be P over RT. And then substituting the terms, we get 3.23 kilogram per meter cube. Okay? Sino? Aldrin. Nandiyan ka pa, Aldrin? Do you want to
Yes po.
continue? So may density na tayo. Ano natin density? So how do we get the mass flow rate?
Mas flow rate po, ano po? Ang formula po ng mass flow rate ay rho
Or,
AV or
okay,
rho
so dito, yan.
times
Rho AV or rho times Q, mass flow rate. However, for our case, wala naman tayong Q na buo. Wala tayong given. So we can use rho AV. We have the rho na. We have the V. So we only need to get the A. Okay, then how do we get the A po?
ano po? Yung
Aha.
ibig sabihin po yung pi r squared po
Yes,
or
pi
pi
r
d
squared or
over
pi
4.
pi d squared over 4. Okay, so using yung 0.35 natin na diameter. Okay, so using all of those, getting the area pi d squared over 4 times velocity na 8 meters per second times density na 3.23 kilograms per meter cube, what will be our mass flow rate? May nakuha, may nakuha ba tayong answer, Aldrin? Okay po. Or sige, Daniel, diyan ka pa ba? Can you ano, try to calculate?
Wait lang po, sir.
Okay. Medyo naghihina ang internet ni Aldrin daw. Dave. May sagot tayo, Dave? Okay, so yes, okay. So, tawag dito, everything, multiplying everything, density, 3.23 kilogram per meter cube times velocity na 8 meters per second times yung area na pi. Again, ang ginagamit ko dito is d na 0.35 meter squared over 4. We get 2.486 kilograms per second. Okay, salamat, Dave. Salamat, Aldrin and Daniel. Okay, any questions po? So, by these examples, you should be able to get, ang critical lang naman dito is yung density. Okay, for liquids, can be direct using the mass over volume, pero for gases, it may not be as direct and you need to use the ideal gas law. After you get the density, then it will just be by the formula. Volume flow rate is AV, multiply by density, you get mass flow rate, multiply again by G or gravity, you get the weight flow rate. Okay, any questions po on the calculations? Okay, so if you're have understood that well, then we move forward with multiple stream flows. So the things that we discussed is still based on a single stream flow, wherein your fluid is passing through one container or one object only, one pipe or one conduit whatsoever. We have cases when our fluid will be flowing or either just joining or separating from multiple or two multiple streams of fluid. Okay, so this is the multiple stream flow. So what will happen here is you have a control volume, okay, and then mass will enter at it through two different inlets, two or more different inlets. Okay, and then the outlet side can be single outlet or can also be two or more different outlets. Okay, for flows involving multiple inlets and outlets, conservation of mass will govern. Okay, so what will happen here is the sum of all the incoming mass flows should equal the sum of all outgoing mass flow. So the purpose of this is to maintain the same amount of mass within the control volume. Okay, so if you do not want the mass to change in a control volume, if you added something like 2 kilograms and 3 kilograms per second, you have to remove the same amount, 5 kilograms per second, to maintain the same amount inside the control volume. If you like to do it equation wise, it will look like this. Okay, so this is the change in mass content in a system that is equal to the sum of mass flows entering minus the sum of mass flows exiting. Okay? And again, our goal is to not have a change in mass content in the system. This should be equal to zero. And if we would like to do that, then our equation will simplify to volume flow rate incoming equal to volume flow rate exiting. Okay? So the incoming or inlet volume flow rate is equal to the exit or outlet volume flow rate. Okay? Any questions or clarifications po sa concept? Okay? Next is, wait lang. So we have this example to illustrate this. Okay? Water and oil. Water, of course, is standard density. Oil, on the other hand, Sg equal to zero point 0.8, enters a mixing device shown. The two fluids form a homogeneous mixture of oil globules in water. Okay. Last info, diameter of outlet pipe is 36 centimeters. Okay. Then the rest of the given can be found on the figure. We have point A, where water is entering. Okay. Volume flow rate is 0.16 cubic meters per second. We have point B where oil is entering. Again, specific gravity of that is zero point 0.8 and has a volume flow rate of 0.04 cubic meters per second. Outlet pipe point C, we do not know the volume flow rate, but we know the diameter, 0.36 meters. Okay, any clarifications? Or I hope, did you, anyone who do not understand or confused with the problem or the goal of the problem? Okay, so moving forward, first question, what is the weight flow rate of oil entering at B in newtons per second? Okay, would anyone like to try to solve this? Uy, yes po, Daniel. You wanna go again?
Sir, tayo lang po. Pag kinuha po yung weight flow rate, pag kukunin mo na po yung density po na po.
Yes, kailangan pa rin siya.
Bali, ang magiging sagot po ay yung weight flow rate po ay 313.92 po.
Can you share yung process or yung steps?
Bali po, yung P density is equal to M over V. Doon po kukunin
Okay.
yung mass. Kasi may density po at saka volume flow rate, which is yung QV is equal to, ay, nga po, yan.
Mm-mm.
0.04. Tapos, yung mass po dun is i-multiply sa 9.81. Magiging sagot po ay 313.92 po.
Okay. Actually, we can use this one. OL. For OL, we have a specific gravity. So we can use that to solve for the oil's density. Okay? And then, since may density ka na from here, if you multiply that to QB, then you will get muna mass flow rate. And then pag mass flow rate ka na, you have to multiply that to G. G is gravity. And then you get uh, weight flow rate. Okay? So ito yan. Parang same naman yung lalabas din. Okay? So this is your what's this? Weight flow rate is G rho GAV. Okay? However, that A and V can be combined to QB, which is available for us. Okay? So G is 9.81. Density is zero point 0.8 times 1,000. Okay? And QB is given 0.04. Then we will get 313.92 newtons per second. Okay? Salamat po, Daniel. Okay? This is the first one. So this is similar to what we are doing during the previous examples. Any questions po? So next naman, what is the average velocity of the mixture leaving at C in meters per second? Okay, so this one is a little bit new, new concept, but it, as discussed earlier, we will follow the conservation of mass. Okay, we are asked for the velocity of the mixture leaving at C, so that is velocity at C. Okay, however, we do not know the Q or volume flow rate at C. Okay. However, we know the volume flow rates of the 2 points where the two fluids are entering. Okay. So by the conservation of mass, the total sum of all the incoming volume flow rates must equal the total of the exiting volume flow rates. So since only point C is the point of exit, then that would be the volume flow rate at C would be equal to 0.04 plus 0.16 or zero point 0.2 meter cubed per second. Okay. Now that you know the Q at C, you just need the A of C to solve for the V of C. Okay. A of C or area at C given by pi d squared over 4, you get 0.1018 meters squared. Okay. And to get the velocity, you just have to rearrange the terms of the formula for volume flow rate. Remember, the formula for the volume flow rate is V, A times V, okay, equals Q. So if you want to get V, then you use Q over A. Be sure lang that the subscripts are the same. Okay? So Q over A, Q is zero point 0.2 meter cube per second over A, which is 0.1018 meters squared. You will get a velocity value of 1.96 meters per second. Any clarifications po? These slides naman I will be uploading after the class so you can review before our take-home quiz this week. Any questions? Okay, and lastly, number 3, what is the density of the mixture leaving at C in kilograms per meter cube? Okay, so this is now asking for the density. Okay, so again, density is different from for all the points A, B, and C. For point A, your density is for water, 1,000. For point B, our density is for oil, which is zero point 0.8 or 800 kilogram per meter cube. So for point C, after the water and the oil has mixed, okay, it will have a new density. Okay, so that density is unknown to us. So that is the question. Okay. Now, how do we get the density? We use the conservation of mass pa rin. Okay. So the conservation of mass states that volume flow rate incoming equal volume flow rate exiting. Okay. It means 0.04 plus 0.16 equals zero point 0.2 cubic meter per second. Okay, so that's the volume flow rate equation for for conservation of mass. Okay. Now, since these three has different densities, then we multiply each of those values by their own densities. Okay, so again, we started this with QA plus QB equals QC, and then we attach the individual densities of each to the proper volume flow rate. So you will get density A, volume flow rate A, plus density B, volume flow rate B, equal to density C, volume flow rate C. Okay, so what we are doing when we attach the density is this equation, rho times Q is actually your mass flow rate already. Mass flow rate at A plus mass flow rate at B equals mass flow rate at C. Okay, so you are just again doing the conservation of mass equation. So substituting all the values, density of A is 1,000 for water, volume flow rate is 0.16 cubic meters per second. For point B, oil, density is zero point 0.8 times 1,000. Q or volume flow rate is zero point zero 0.04 cubic meters per second. That will be equal to density C, which is unknown, times QC, which is the total volume flow rate exiting the mixing device, or zero point 0.2 cubic meters per second. Okay, so from this equation, if you would notice, only density at C is unknown. So we can solve for density at C. We will be getting 960 kilograms per meter cube. Okay, so if you would notice, this is a value different from A and B. And the value also is in between the densities of A and B. So A is 1,000, B is 800. Our exit density becomes 960. Okay, so it means the density of the outlet is dependent on how the two fluids will mix. Okay, it's not always 50-50, it's not always the average density. Okay, any questions po? Okay, now if you have no more questions, then that is actually the last item of or topic for tonight already. I did not put too much information for now because yun nga, I think some of your spirits are still in the cemetery and kumbaga you're not in the mood to listen yet, or maybe you are hangover from all of the typhoon and the breaks and the midterm effects of midterm. So a little bit light topics today, but starting next week it will be more serious na. New topic next week, a little bit difficult, little bit more complicated. But ano, yun nga, we need to bounce back as as esteemed students of the Department of Mechanical Engineering. We have to prove that we are the best again. So next week, I hope that you will be all alive, alert, awake, enthusiastic again in our classes. Okay, so any final call po for any questions? Okay? So this week we will have again a quiz number 3 that is all problem solving based on today's today's topic, rate of flow. Rate of flow for liquids, rate of flow for gases, the one using ideal gas law, and rate of flow for multi-stream fluids. So yung multiple inlet, multiple outlets. So I will be giving that in the middle of the week, maybe, and I'll just post in the classroom when will it happen. And then you have to submit also to the classroom once you're done. Okay? Any concerns po or questions or anything? Yes, Alvin.
Sir, excuse po. About po sa PSET, kung puwede ko daw po kayang ano, i-rewrite po yung PSET na naunang maipasa. Kasi yun daw pong una ay madumi. Pero same answer lang naman daw po ang ilalagay.
Define madumi, like magulo?
Opo, magulo
Or
daw po.
nagdumi na ng bagyo? If
Parehas daw po.
madumi... Ha?
Parehas daw po.
It's no need na. The physical printout basically is pang-audit ko lang siya. Sometimes I will check sa the physical, sometimes I will check with the digital. Pero what I want kasi is the physical, the one purpose of the physical kasi is to check na inyo talaga 'yon. Because yun nga may mga some of us kasi as guest lecture discussed, may mga times na submissions in the class, same yung sinasubmit, pero they find a way kasi na tawag dito, s- yung parang magkaiba yung name sa naka-attach sa Google Classroom pero pa nung sinubmit nila. Pero I mean, magkaiba ng name sa Google Classroom. But if you would put them side by side, pareho yung content. Okay, so that's one. That's one thing that we are preventing. Second is mas madali kasi talaga mag-check ng physical. Just flip pages ka lang compared sa Google Classroom na hintay mo pa mag-load. Tapos scroll down, tapos minsan kailangan mo pa i-zoom. So it's taking time. If so that's why we want in the physical copy. Now, no worry if it is a little bit dirty na, either because ganun mo talaga siya ginawa or something because of the typhoons. It's okay, no need to rewrite. I will just, for your case, for that person case, if I cannot read something on the printout, I will get it from the GCR na. Yun lang naman yun. But again, I'm not, kumbaga, wala naman akong concern sa how perfect your writing is or the paper itself. No need na. So I think if only for the purposes of para mag-presentable siya, no need na. Unless like nawala mo talaga or nasira siya. Other concerns po? Keep nyo lang yan. I think our next face-to-face is next week. Meron tayo. Let me check. Sunday. Yes, we have on Sunday. Face-to-face. That's November 10. Okay, so I may be collecting those in November 10. However, yun nga, checkan ko na siya. I'll try to check it by this week. Pero I feel kasi sa dami nun, I cannot. So, may matcha-checkan pa rin ako using the hard copy talaga. Okay. Any other concerns po? Okay, if no more po, then that would be all for today. Again, ingat po sa mga babalik pa lang ng Batangas City, Batangas, or ng GCH kung saan man kayo nakatira. And yun nga, I feel everyone naman, even as professors, we feel like 5 weeks na hindi kami nagturo. We felt disconnected din sa lectures, nakakatamad gumawa ng slides and all of that. But hopefully, slowly, we start become busy again, we bounce back, we regain our focus, and yun, bawi tayo sa mga upcoming activities natin para pass with flying colors tayo by the end of the sem. Okay? So if nothing else po, yun lang po for today. Bye-bye po and see you next week.